when we are going to join, right, the two data sets, so there are two types of join in the MapReduce. Mapside joins are okay. So one is a mapper side join and one is the reducer side join. So map side join. So when the small data set which fit into the memory, so we use the distributed cache concept. Okay. So yesterday I was talking about some like emp.txt and department.txt. Right? So here emp.txt I will use as a mapper, but department.txt I will not use the mapper. I will be feeding through the distributed cache because it's a small file, just some KBs of file, right? Hardly 5, 10 or 15 department, right? So that is not a very big information. So I can read through the distributed cache. So distributed cache is a way like I can read a small file in the memory, okay? And then I can load into my hash map in Java, and then I can get the data from the department.txt. So department.txt has the two fields, dpt ID and dpt name, okay? And the employee.txt has employee ID, employee name, okay, and other fields are there. And one more field is department ID. Generally, you have seen this kind of data, right? So I want to do concatenation. I want to create output data. So this is my two output input file. So this output I want to, like after the join, I want the output employee ID, employee name, and DPT name. Okay. Or you can say like DPT ID also I want to print and DPT name. So here, this department ID is common. So if I have a data of this department as a hash map, right, key value pair, so I can look up the data in this department ID, department name I can get, and then I can concatenate the data. Okay. So this type of join is called mapper side because here is no reducer. Here is no reducer required. No reducer required because we are simply so first when I'm reading the data, so I'm splitting the data and then I'm getting this field, then look up this field in this department.txt hash map and get the department name. And then again, I will concatenate again, comma delimited. So it's like a, you see here, there is no calculation required. It's simply the mapper output will be this concatenation. So this is like a mapper output. Okay. So mapper output data. Okay. So here is no reducer required. That is the reason it's the map side join. So joining thing is happening at the mapper end, and the output file will be the part hyphen m hyphen 000. So I showed you, right, whatever program we did so far, right, partitioner, combiner, or word count, we got part R. So why we got the part R? Because our output is coming from the reducer, the final stage. But here is no reducer. The output is coming from the mapper. Okay. So output is coming from mapper. Okay. Because there is no reduced task. There is no reduced task is required, right? So the output is coming directly from the mapper, mapper. So that is the reason the output file name will be part n. Okay. So that is my map side join. Okay. So I will show this one, right? How we can load this department.txt, get the hash map data, and then this is usually we do the same way as a mapper. So we will read the file and then split the data. Okay. And we'll get as a array index. Okay. And another join is a reduce side join. So reduce side join is where the joining is happening at reducer end. So joining is happening at reducer side. Okay. So this kind of scenario is when two different mappers are there, two equal amount of data is there. Map side join we can do, one is a large data, one is a very small data. So like emp txt, I say it's like a 1 GB file is there, right? Okay, like 100,000 employees are there, but department is just some KBs, right? Very, very small, one like 10 KB or something. Like I believe it's even the 1 kilobyte is small, right? So department ID, department name, right? So hardly 10, 15 department max to max, right? Like it's like in any department, right? Department will not be in more. Okay. Here joining is happening at the reducer side, and here is two different mappers will be there, like two equal size of amount of data is there, two equal size, two equal size of amount of data. If I say the order data and customer data, so how many customers will be there? At least those many number of orders will be there, right? So customers like one to one, like one customer, one order, or one customer can have many order also, one order, right? One order, or sometimes like one customer has one to many order. So I will say like the data size amount will not be much difference. Okay, so both equally like the size of the data. So here two different mappers will be there. Like one mapper will be reading the data of customer, and one will be reading the two different mappers will be reading data. Like one is a customer mapper, okay, and another one is a order mapper. So these two mapper will read the data, and after shuffling and sorting, right? So the reducer side, we have to do the calculation, right? One customer has how many orders are there, and one customer has what is the cost of the order. So I want to know customer wise, I want to know customer wise the order cost, right? Okay, this particular cost. So I want to get like this customer ID and total cost and total transaction. Okay. So suppose I have a three customers. So one customer, second customer, and third customer, and the total cost, right? One customer has two orders, and total amount of the order is like 50 plus 50. So total is 100. Okay. And total transactions are two. Another customer is having only one order of 75. Okay. So I say 75, and the total transaction is one. So like this output data I want, and suppose one customer has like one order 25, one order is a 50, and one order is a 50. So total is a 125. Okay, I'm just taking an example. Okay, and here is the transactions are three. Okay, so I want to display output like this. Okay, so this we will do with the reduce side join. So two different scenarios. One is map side, one is reduce side. Okay, so so when we are going to join, right? So first of all, we have the two data set requirement. So, okay, first I'm showing the map side join. So map side join, I told like there is no reducer required. So there is no reducer file is there. So one is the driver class, one is a mapper class. Okay. So I just named it driver map side join distributed cache text file, and mapper map side join. So I'm having a two class. So first understand the driver class. So driver class, we know these are the basic property of the driver, right? Job dot set jar by class, so driver class name, and the file input format, file output format. Can you see here the reducer is the 0, right? Because I know this is my map side join, so there will be no reducer. So I already set my reduce task 0. Okay. So this reduce task 0 property, when I set like this, so there will be no reducer class required. Okay, there is no reducer class required. And the other thing is, I'm just setting my output format, right? Text type format. So I'm setting it, and this is the line for deleting my existing directory and creating again new, right? So that I don't need to create again and again new directory. So distributed cache is what? Distributed cache is like sometimes the small data is there, and what I want to do, I want to load in the memory from the disk directly. So I don't want to read as a mapper. I don't want to read. Okay. So if this is a very small data, even I can read from the mapper, but I want to keep it in memory because it is reusable file. Okay. So what I did, I have in my Hadoop directory. So in Hadoop directory, I'm creating a one distributed cache. So what I'm doing here, like mapreduce WC DC is a distributed cache, and this is my text file. So this particular text file, if I show you this distributed cache text file, so this one has the department ID and department names. Okay, the two fields are there. Okay, so what I'm doing here, I'm loading this file, this cache file, I'm loading in the distributed cache in the driver. Just I'm adding a file in the cache. So next, when I come to the mapper class, so we know, right, uh, in the mapper, first of all, I have to find my cache file because I have to load the data from the cache file in the memory. So I will be using the setup function of my mapper class. Okay, this is the setup function. So setup function is an initialization function. Like before calling actual map function, this is the map function. So before calling the map function, this setup function is called. So if you are not providing any setup function, so there will be no initialization you want to do. Directly you can call the map function. But here is a scenario. I want to read my distributed cache file, right? Because in my disk, right, there is a distributed cache file. I want to match because there could be many files. There could be other different distributed cache file can be there, small file. So I'm going to read my required file, right? Whatever file is I need, I'm reading only that file. So I'm just matching here in my file path. This is a path object. So I'm reading the cache local cache get local cache file path and getting all file path and finding my department.txt file. And once I find my department.txt file, okay, this is the counter. Okay, we leave it this. And I'm calling a one function load department hash map. So what I'm doing is I'm reading the file path. You know, right, in Java, there is a logic how to read a file. So how to read a file in Java? There is a buffer reader, right? This is typical Java code, okay? Right, reading a file stream, right? Buffer reader, file reader. So the department ID and department name are comma self-delimited, okay? So what I'm doing, each line I'm reading and separating by comma and putting in the map as a key and value. So key will be department ID and name will be department name. Okay. So once I return this hash map, I load this hash map, and in the map function, so map function first, what I'm doing here. So this signature I told you, because my offset is a key and value is a text and context is a parameter where we are writing the data to share across the machine, right? So context is the common shared variable. So when I say here, I'm just splitting the employee data. So definitely I'm using this mapper for employee.txt, not for department, because department.txt data I loaded in the hash map by using the distributed cache. Okay. So in the map function, what I'm doing here, first I'm splitting the all columns, all values. There are the 5 or 6 values are there. Okay, I split it out and getting the department ID. So in the hash map, in the hash map dot get, right? This hash map dot get, if I pass the ID, department ID, that is a 0, 1, 2, 3, 4, 5. The 5th number of column is my department ID. So when I pass the department ID, that is the index 6, so I will get the department name. After that, I'm preparing my output value, like how I want to display the data. So I'm making it tab separated, /t, /t, /t. So I'm making it all the field tab separated, and this department name I'm adding a last field. Okay. So final output I'm writing in the context. So this the concatenated string. This is a concatenated. This is concatenated by tab. Okay. And the key I'm just setting the employee ID. That is my 0 index. Okay. So I'm setting my context dot write. So this will be my output only. So there is no further more class in there because this is my final output. That is the reason here is no reducer required. Okay. So, so first of all, I have to verify whatever the distributed cache I am using, right? So whether my distributed cache has that file or not. Okay. So I just check in my Hadoop location. I check in my Hadoop location. So I have already started my Hadoop service. Okay. So I'm checking first this location, whether my distributed cache file is there. Okay. Can you see here the department underscore txt file is there, right? So these are the byte. So this is just hardly byte, right? Okay. So when I say Hadoop fs minus cat, then I will see the data of this department.txt. Okay. So this is a fixed location, right? Because I know in the Hadoop file system, okay. So for this program, I will be running on the Hadoop file system because I'm taking this location in Hadoop file system, right? So if my input file is in Hadoop file system, so my output will be on Hadoop file system, right? So I will need to create a jar of this project. So have you seen that? This is my distributed cache, right? Department.txt file. This is a department ID, comma, department name. How many departments are there? How many departments? 9, right? 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now check employee.txt file. Where is the employee.txt file? So employee.txt file, let's see here. So last time when I run this program, so my file was already there. So can you see employee.tsv file is there? Okay. So let's see what is the file. Okay. This is also not very big file. Okay. This is also not big, but we are testing the logic. Okay. So Hadoop fs minus cat, and this is my okay. So this name looks like a TSV is a tab separated value, but this is just a name. Okay. So don't be confused. The actual data we kept it comma delimited. So can you see the data is a comma delimited? Like first is the employee ID. This is date of birth, first name, last name, gender. I think this is something. Okay. So this will be date of joining or something, right? Okay. Maybe this is a date of birth. Or what is this? So something is a date column. Okay. And this one is the last one is a department ID. If you see D005. So D005 is matching here. D005, right? And if you see the second one is a D007. D007 is there. Okay. So all these IDs are matching here because this employee.txt has all data, right? So this all matching data. Okay. So we have one input file and one is the department.txt is a distributed cache file. Okay. So first what I need to do, this is my driver class, right? So I have to create a jar of this project. Create a jar. So there are many other classes are there, but I will invoke my driver by driver class name, right? So you know, right, when I'm giving this particular class with the package, so I will particular this mapreduce driver class I'm running. Okay. Otherwise, there are many other driver classes are there, right? Okay. So jar is only one, but I'm not creating a separate jar for the separate program, right? So I kept it everything in a one single like a Java code, and I'm just doing testing. Okay, so my jar is created in target folder. Okay, so I will copy this jar and keep it in some location. Jar I kept it here. Okay, and I will start a terminal here. So how to write a command? So I have to write a command. So department.txt, I will not provide my input path because it is part of my application, right? It is part of my jar, right? In my driver class, I'm reading from the cache file. Okay. So if you see here in the driver, this is a driver. This is a driver file. Okay. So first I will give Hadoop jar. This is a command for running a jar in the cluster. Then I will give my driver jar, the Hadoop jar map. This is my jar. The next thing is a driver class. So my driver class is org.example. This is a package, and this is my driver class. This is my driver class. After that, I have to provide my employee TSV file location, the employee file. So employee file is, this is my employee file. This is my employee file. So I have to give complete path of the file. And I have to give one output file. So output file, what I will do, I will keep the same location, mapreduce WC, some new directory I will give. I say map side output. Okay. So I have given map side output. Any name is fine, right? Map side output. And this is the directory where my output file will be created after the join. Okay. Now enter. Now my MapReduce job is started. So it is starting with the, you will not see here reduce 100% because reduce is not there. Did you see that? Because I made it reduce number of reduced tasks 0, right? In my driver class. Can you see reduce is increased or not? No, right? Because reduce is started 0, ended 0. But map is started 0, ended 100, right? So map task is completed. Okay. And here we can see how many records map read. So map input record 7. So we are reading 7, okay, like your employee data, right? The 7 record. And what is the output of the map, right? Because there is no reducer, right? So, yeah, map output record. So this is also again coming 7 because I told you, right? We are just splitting the data, concatenating department name, and then again we are creating the same text, right? So it means number of record will not change, right? The number of record will remain same. Okay, let's see the output. So Hadoop fs minus cat, and what is the directory? The output directory. The output directory is this one. This is my output directory. Output directory, but I have to give file name. So file name is a pre-decided. Why it is pre-decided? I told you whenever mapper output file is coming, it will come part n. Don't try part r because it will not be part r. It will be part n. And how many zeros are there? 5 zeros. Can you see here? It is a tab separated data is coming. Initially, when you give an input, it was a comma delimited. So this is the one column, this is second column, third column, fourth column, fifth column, sixth column, department ID, and then last is coming your corresponding department. So D005 is a development, right? D006 is the quality management. D004 is a production. Can you see the same? D004 production. So this is called mapside join. Okay. So mapside join is a join which is happening at the mapper side So there is no reducer required. Okay. So this kind of example where you don't need reducer, just you need to concatenate data. So you can split your mapper data and lookup you do and find the distributed cache, get the department name or something like you can look up and add in your original data. Okay. So this tab or comma you can change. It is up to you because I added as a tab separated because it will be more clarity. But you can make it when you are preparing your output data. Here you can use any separation character. You can use /t, dollar, anything you can use. Okay. Is it clear, everyone? Like what is a map side join? So definition of the map side join. So you see some example, you will understand. And this map side join same we will see in the Hive. The context will be the same, but there we will use as a table. Here is a two data sets are there, but in Hive we will use the table, but the concept is same. Like here we are using distributed cache for loading the data in memory, and there we are the small table which can fit into the memory like department table, and we will load into the memory using the map side join. So map side join, the concept is same, but there we will be applying the map side join in Hive on the tables. Okay. Okay, so this is clear. So another program is reduceside join. So reduceside join. So one single class I have a reduceside join because here different mapper and driver all are in the same class. So either you can create a separate class, right? Or you can create a static classes. So static classes are the inner classes, right? So one single class, and that class is a driver itself. Name is a driver because any class you should have at least one main function, right? So one main function you are defining. So definitely the class, this particular class is a driver. But the other classes we are defining in this driver, that will be different classes are there. Okay. So one class we need mapper class, so customer mapper, and one is a transaction mapper. So I was talking about the customer and order. This is the same example, just the name is different. Here is a customer mapper and one is a transaction mapper. So first what I'm doing here, so my customer data is there. I will be separating this customer data. I will be splitting the data like comma delimited data. And then I'm taking a customer ID and this is my order. Okay. So first I show you the data, right? So you will get more clarity about this. Okay. So this is my reduceside join program. So let's see that where the data is available. Okay. So the data location is this one. So in my home mapreduce, this is my local directory. Okay. You can easily identify this is a home directory or Hadoop directory. Okay. Generally the Hadoop directory I will not give here because Hadoop directory I can give, but I cannot run here, right? So there is no point to give here, right? So whenever I'm running in IntelliJ, I will be always testing the data locally, right? But suppose the same example, this reduceside join, I want to test in the Hadoop file system. So when I'm giving this path, I will give in the Hadoop jar command. I will not give here, right? But the IntelliJ is a way, right? Like if I want to run locally, so I have to pass the parameter, right? The same path which I'm giving in the Hadoop jar command, this Hadoop jar command, I'm passing the parameter. So I can pass in the IntelliJ by using the command line parameter. Okay. Like this is the one way to pass the parameter. So space delimited, like if you see the first parameter is still here. This is the first parameter. Okay, because space separated parameter is there. Okay, so this is the first customer detail and space is there, then the second parameter. So I told you here we need two mapper, like one is a customer data, one is a transaction data. So one file is a customer detail and another file is a transaction detail, and one more third parameter will be here, that will be your output directory location. So output directory location. So total 3 parameters will be there. So you will be reading 2 parameters for the 2 input file, and 1 parameter you will be reading for, like you are telling about what is your output directory. Okay. So I go to my this location, I will get my mapreduce underscore wc data. Okay. So I will check mapreduce wc. Here is a data folder, and data folder, if you see the two files, customer detail and transaction detail. Let's open these two files. This is a customer detail file, and the second file is a transaction detail. So can you see what is common in this? So customer detail is a customer ID, customer name, first name, last name, age, and the profession. Okay, and the another one is the transaction detail. So transaction detail, there are the transaction IDs are there. The transaction ID is like 001, 0002, 3. And here you see, this is a customer order cost. Okay, like 45.67, $78.67. But can you see before that, this IDs are what? What are these IDs? These IDs are the same like a customer ID, like 40001, 4002, 4003. Same you can see here, 40001, 4002, 4003, right? The same IDs. So here joining, you can say customer ID is joined, like customer detail customer ID is joining to the transaction detail customer ID, right? That is a common. So you can see here, if I say number of transactions, can you tell me how many transactions for the customer ID 4001? How many transactions are there?
Two.
Two.
The customer ID 2, how many transactions?
One.
One. Customer 3,
One.
one. And customer 4, because we have 4 customer, right? 4004. How many transactions for customer 4?
Zero.
Zero. Okay. So when I will get the result, so for customer 4, 0, customer 3, 1, customer 2, 1, and customer 2, customer 1, 2, and customer 2 is 1, 1, 2 and 3, right? So this should be the my result. Same way, like if I do the total, right? So my total will be approx 45 plus 78, whatever it will come. And these are the 1 transactions. Okay. And for customer 4, the output will be the total cost. What will be the customer 4 total cost?
Customer 4. I don't think they have a zero.
Zero. So if it is not there, the 0 calculation is 0, right? Because we are talking about the calculation will be 0, right? Okay. So we know the result, like this result will come, but we have to, this is very small data, right? I'm just calculating manually, but I'm talking about these records are not for, right? This transaction customer, we are talking about the GBs of the data, right? That's a Hadoop, right? So Hadoop MapReduce is processing the large amount of data. This is just for testing. I'm just testing my logic. Yeah, I told like I want to test my logic in the IntelliJ, and then I want to do the analytics on the large amount of data. Okay, but first my logic should work, right? Okay, so how I'm writing the code. So what I did here, so what the logic, two different mappers are there, right? One is the customer, which is reading customer file, and one is reading the transaction, which is reading the transaction data, right? So what I'm doing here, I'm reading the part of 0. I'm saying context dot get part of 0. So part of 0 is in the customer. What is that? This one, customer ID, right? So customer ID I'm adding as a key, and value I'm adding as a part of 1 with prefix is there, customer. So what is the purpose of this prefix? Yesterday I was telling, right, because if you don't add the prefix, so when these two data will go to the reducer, the reducer will confuse, right? What is the purpose of this data? What is this data all about? Is it some number data or string data? We cannot know, right? Because if it is a string data, I have to use this data for display purpose, right? If this is a customer name. If it is a transaction data, right? Some number data, right? Some float values data, right? So that means it is a some cost, right? So it is a calculation data. Like I have to use this data as a calculation data, right? Okay. So it is a string data, it is a customer data. So that is the reason I'm adding a, when I'm adding in the customer mapper, I'm adding a customer prefix. When the transaction mapper, I'm adding a transaction prefix. Okay. But here I'm adding a part 2. So what is the part 2 here? Part 2 in the transaction, you see part 0, part 1, part 2. It's the same customer ID only, right? Because the customer ID is common, so we should have the key should be same in both the mapper, right? In both the mapper, this one is equal to the this one, right? And this one is the name, right? This is the customer name, and this is the cost of the transaction, right? So I believe other information is not for my use, right? Because I don't want to display the other thing. I want to display the customer name and customer total cost and how many transactions are there for the customer. Okay. So I will identify the number of transactions by this transaction, like how many times I'm adding the amount, right? So I can know. And the next class is the reducer class. So reducer class, the little bit logic change here. Previously, you seen the logic. I was straightforward. I'm making a count variable and count plus plus I'm doing for the same key, right? But here is data is coming from the two mapper. Like sometime data is coming from the customer mapper, sometime it is coming from the transaction mapper. So here, what I did first, whatever data I have added here, I have a, what is the delimited character here? Like a space, right? Some space is there, or I can add hyphen or something. So whatever I'm giving here, the separation character, the same separation character I will use here and divide the data into two parts. So one, I will get the prefix, like this transaction or customer, cust. So this prefix I will get it, part of 0. The part of 0 is my prefix and part of 1 is my either name or the transaction amount, right? If it is the transaction, so what will be my part 1? The part 1 will be my amount. If it is a part 0 is my customer, what will be my part 1? It will be name, right? It will be name. So that is the reason I'm storing in the name. If it is a part 1, if it is my part 0 is transaction, so definitely my part 1 will be my amount, transaction amount. So what I'm doing here, simply total equal to 0, 0.0, and I'm adding 0.02 multiple transaction amount I'm adding. Suppose this customer has 3 times order. So how many times it will add it here? For the same customer, 3 times. Okay. So automatically number of times you add the amount, so number of times transaction count will be increased, right? So I started from the 0. So I'm assuming it like customer 1 has 3 times order, 3 times transaction. So how many times of count will come? 3. And how much total will come? The number of times amount is there, right? Okay. So finally, I got the total and now I got the name, right? So what I did finally, write context or write, I can write key and value, right? Because everything is written in the key and value format, right? In the MapReduce. So name I'm using as a key and value what I'm doing, whatever is my count and transaction amount, I'm just preparing in the like a space separated. So %d is for integer count and total is the float value, that is my amount. Okay. So once this string is prepared, this format, the string is prepared. So I'm just writing the data to the output file. So again, I told, right, basically we are using a Hadoop file format type, like text format. Okay. So my output will be like this. My output will be like customer name, customer count, transaction count, and total. Okay. So like first customer is a customer 10001 or 4001. 4001 is transaction count is 2 and total amount is suppose approx $125. Okay. Not saying exact one. So that will come. So 4002, we know the transactions are one count and amount is suppose some 67.0. So like this, I will get the 4 record update. Okay. Okay, so up simply I have written this code. Nothing is this in the code. Just the one driver class, the main class, main function, and I have a reducer class. So reduce class is there, and two mapper class, one mapper and second mapper, customer mapper and transaction mapper. So I will run my this driver class. So I'm testing here first in my locally. So I will reduce side join, and I will edit it. So I will verify. So here is my the application name. This is my driver class name, right? Whatever my class. So I will give the driver class. And how many parameters are taking? 3 parameters. Okay, let's verify in the driver how many parameters we are reading. Can you see multi-input format I'm using? So multi-input format is like you are using the 2 input for your input file, like 0 and 1, and 2 is for your output path. So total 3 parameter using. So here is special different type of input format we are using, right? So this is a multi-input format. We are using 0 and 1 for the 2 different mapper out input file, and 2 is for the output file. Okay. So and what is the output directory? So output directory is in my mapreduce WC. There is a output rejoin is there. Okay. So if I have written that part, right? If it is deleting a directory and creating a new directory again, so I don't need to create a directory. Okay. But suppose it is not there, then I can give a new directory name. So just I verify in this directory, there is no output rejoin is there, but output underscore rejoin 1 is not there. Okay. So I'm just applying. Okay. And I run my. The same program, if you want to run on the cluster, you have to create a jar and you have to provide 3 input, 2 for the input file and 1 for the output directory. But these input files should be on the Hadoop file system. It's completed, right? So if I go to, so my new directory is created. This is the one, right? Output rejoin 1. When I go inside this, so I told, right, okay, this is the output is coming from the reducer, right? So definitely the file name will be part-r. Okay. So now you see, is it a correct output? Just match it with the transaction details. Okay. 70. So this is a 1-1 transaction. So same amount will be there, 78.67 and 89.90. Okay. And 0 is 0, right? Both are 0, 0. So 0 is count. Okay, it is coming not customer ID, it is coming name. So name you can match. So customer 4 has the name is test6. Like the same name is coming. So this is the expected output, right? The customer name, customer transaction count, and customer total cost, amount cost. Okay. The same program you can run on the Hadoop. Okay. So you guys try, because I don't want to do, because I want like you try the same thing. So first of all, you keep it jar somewhere once you create a jar. So after creating a jar, the jar is very simple. You should have a one, you should have a jar like now you can any Maven Maven like a task is there, right? Okay. So here it should point to your Maven project. Okay. So your this entire project jar will be created. Okay. So when you do this and click on OK, jar name, everything will remain same, right? It will never change. Okay. So jar will same, because in the pom.xml, we define here the artifact name. So jar is always create in this format. Mapreduce WC is your artifact name, and this is the version, and dot jar. So like your jar name will be created mapreduce 1.0 snapshot dot jar. That will be naming convention of the jar. You can see here. Okay. So once when you start this, your jar will be creating, and you copy the jar in the some folder and create an input directory. Okay, and keep it your file there. So like I kept it here, my input file. If you have seen here, I kept it my input file. Yeah, so two input file is there, customer detail and transaction detail. So copy in a one single folder, one input directory in Hadoop file system, give that path. So your command will be, I showed you the command. So your command will be Hadoop jar, jar name is the jar which is created, and then your driver class name, form.org.example. Okay, and dot, what is the jar driver class name? Reduceside join. So reduceside join is the main class. So this will be my driver class name, and the two input path is needed. So suppose I'm creating some directory, map reduceside join. Some new directory you create, reduceside join, and say that the one file is a customer detail. So copy their customer details file, and then second path is a reduceside join, same directory, and keep it there, transaction underscore detail. Okay, details. Okay, and after that, the last path is a output directory path. So that you say, okay, reduceside join is my main directory, and you just create some name output, any name you can say. So when you see after running this Hadoop jar command with this jar and everything, so you will see your output will be coming in the same directory, the same output, this part R. So this file will be created in this output directory. Okay, this command you have to use. Okay, but you have to upload the data, right? You have to copy the data in this new directory. Okay, I can show to you, but I want like you try it. Okay, try in the Hadoop file system, right? How to copy the this input file. Okay, but your jar will be in local file. Jar is whatever you are running your terminal, right? So jar will be in the same location, right? Suppose my jar is in this location. So if I do ls, so my jar is here. Okay, and then you do this command, the Hadoop jar command. Okay. Okay. Anyone has any questions? Because MapReduce, this is the last topic of MapReduce.
Yeah, I had questions. So for both mapside and as well as reducer side joins, are both of them still using distributed processing?
See, here is no distributed cache is there, because I have not used the cache file. But suppose you say like you have a very small data set, then you will bring the distributed cache in the picture. Okay. But here is both data is very large, but still distributed cache is common concept. It's not only just map side join, even the reduce side join also can use. Okay.
Yeah.
Suppose I say I want to keep it some constant, right? I say I have like I say okay, suppose I am doing this customer and transactions, right? Order. So I have some location wise my stores are there. So those things I can keep it in my distributed cache file. Like I can prepare one distributed cache file. I say like one Walmart store is there. I say it is a comma location one store. Okay, some location one. Same Walmart, another one is there. Okay, I just keep it different one. So Walmart is one, and I say CVS is one, right? So location two. Okay, this type of key value pair constant I have. And in my input data set, like when I'm saying transaction, so definitely whichever store I'm doing, I have that store is here, right? I say Walmart is here. But I want its location I want, but that location is not in the data set. So that part I can do the distributed cache. Okay. So whatever part I did in the mapside join, right? I load the cache file, right? So same thing you can do for this kind of data. Okay. So distributed cache is not restricted to the mapside join. Distributed cache can be used in the side join, but you have to write entire coding part, right? Whatever you did, load hash map, setup function, right? So in the one mapper class, so you have to find in which mapper class it is required. So if it is a transaction detail related mapper, you will use in their setup function. You will read the distributed cache. But suppose something is customer detail is there, like I'm not using this. I'm saying okay, customer detail is a one type of field. Okay, transaction is having one is a credit or okay. So suppose I say here profession is there. So like I want to something relate, okay, right? Something field is which is like I can use the key value pair type in the distributed cache. So you can pass the key from here and get the value from the distributed cache. Okay. So distributed cache can be used either in the customer mapper or transaction mapper, depending on where that key is there, right? For the distributed cache of data. Okay.
Okay.
So distributed cache can be used, but like if mostly like if my this is the reduceside join, right? So different mappers already like different mappers are there. So that use case is like where we are doing mostly the concatenation data. So there I use the distributed cache, right? I don't need to use any mapper for this kind of data, right? Because it's very small data. Okay. So that is the reason I go for mapside join there. I don't have any calculation, just I have to read the lookup data and then concatenate the data and get my output data. Okay. Okay.
Yeah, because
If you
I
have the
was
calculation, you have calculation right here, because here is like customer orders, customer transactions, something like where you have to do aggregation. Okay. Like word count aggregation. So word count is also aggregation, right? Like same key is repeated. So same is here, like customer ID is repeated, right? In the transaction multiple times, and you are aggregating the result. Okay. So you can see the transaction count you are doing. That is an example of word count, right? Right. Okay.
And one other question I had is you mentioned before the shuffle and sort, which happens between the map and the reduce. If we go with this way, do we still use it on the reduce side join?
See,
Or
shuffle and sort will be definitely there, because if reduce side join is there, if map side join is there, so there is no shuffling is required because your data is not going to the right. But if it is a reduced side join, so the shuffling process will definitely come, because this is a shuffling only, right? We have a customer, multiple customers. If you have seen in the code, like then finally when the data is coming to the reducer, right? In the reducer, right? So here is different mappers data is coming, right? So we are trying to identify which mapper data and what type of calculation we are performing, right?
Yeah.
And accordingly, then I'm preparing my final output.
Yeah.
Okay.
The string. The name is what's the key, right?
Yeah, calculation. So shuffling is, because if shuffling is not there, so how we can get the same data from the different mappers? We can't get it, right? So shuffle and sort, I told it's an internal process, right? That is not in our control. Okay. But number of reducer output file we can apply. Suppose you want to say, see, partitioner, combiner, all these concept anywhere can apply. Those are the general concept, right? Partitioner and combiner. So if you just write whatever your reduce side join class, reduceside class is a reducer class. Same class you can enable in the job dot set partitioner job dot set reducer class and job dot set combiner class. So you can apply the combiner. Okay, but combiner
Okay.
effect will come when you have repeated key and you want to aggregate in the mapper side. And
Okay.
partitioner also you can apply. Suppose say the same as all output data you are getting in a single file, right? This one. Suppose you say,
Mm-hmm.
I want to do some calculation like uh like I say if I can take the cost also as a value, right? Key value pair. So customer ID I take it as a key and value I take it as an order cost. Okay, in my partitioner, and I put a check if the if it is more than $100, it will go to one file. If it is a $500 in one file, and if it is a $5,000, like I can put a condition, so I don't need to search the like which like I have a three variation, right? Okay, if order is less than $100, I will check that file. If I have 100 to
Mm-hmm.
$500, I will check the second file. If 500 to
Mm-hmm.
$1,000, I will check in the third file. So
Mm-hmm.
what output you are getting in a single file, you are just distributing output into multiple file, multiple reducer file, right? Multiple output file. So
Yes.
so this is in your control. So
Mm-hmm.
reducer is in our control, right? We can create
Mm-hmm.
as many as number of reducer, as many as number of output files, right? Okay. So mapper is not in our control. Mapper is whatever our data is reading, it will be divided the block size and distributed in the number of machines. So we cannot control that. But reducer we can control because output is in our hand. Based on the partitioner, I can send the data to the specific file I can send, right? If
Mm-hmm.
I don't use partitioner, it will go everything in a one file, right? Okay, so partitioner combiner, see mapside join, reduceside join is a just joining strategy, right? Two ways of joining the data. It is
Mm-hmm.
not like a partitioner combiner is a general concept. So that can be used even simple word count program or mapside join or reduceside join. So so anywhere you
Mm-hmm.
can apply the partitioner and combiner. So these are the optional I told yesterday, because these are the one is the performance related and second one is the ease of, right? You can find your output data, right? So it is giving you
Mm-hmm.
the easiness, right? Right. If you write all output in a single file, that is better, or you can divide your output into multiple files. That will be bit better, depending on the criteria.
Okay.
Okay. So for interview point of view, like see, nobody will ask this much coding, right? Whatever I showed, but I say, right, if you know this concept and anybody who can speak about the MapReduce concept, I will say out of 10, only one person. Because people don't learn the MapReduce concept because they think, okay, MapReduce is nobody's asking in the interviews, right? Because people think it's outdated. But you know, right, everything is key value pair and all the technologies have the MapReduce. Even Mongo is using the MapReduce, like key value pair, right? So key value pair is not outdated concept, right? Even Java is using hash map, key value pair, right? So key value
Mm-hmm.
pair everywhere is there. In the dictionary is a key value pair, right? Okay.
Mm-hmm.
So
Yeah.
any language you see key value pair is there. Yeah, but how map and reduce works? Okay, and it is a completely Java code and it's very lengthy code. That's the reason people don't prefer it. They prefer Spark, right? Because Spark is doing with library functions. So same map reduce, you will see whatever you written for map, 50 lines of code. Okay, reduce you written 50 lines of code, just I'm assuming, and driver is suppose 50 lines of code. Okay, and when you go in the Spark, so there is no separate driver class is there in the Spark. So just only map function you call in the Spark. It's a one line of code. Okay, and when you say when you call reduce, it's again one line. So total 2 lines of code you can do word count, 2 lines of code you can write word count. Can you see, like, productivity wise, if I ask one guy, you write Java program, MapReduce, and you write a Spark program, who will write the code first? Sure, 100% 2 lines code is 150 is like copy paste is a different thing. Okay.
Mm.
But I'm saying like actual hard work, right? Actual I will say writing effort, right? So it will 150 lines. It's only 2 lines, right? And execution is faster here, right? But internally everything is use MapReduce, right? So it is very important to understand concept, not for the working purpose, not for the you will not get a chance to write a MapReduce code. But if you understand the architecture of MapReduce, so you can think of how other APIs or libraries or like how it is internally using MapReduce. Okay.
I have one question quickly. It's just that for doing MapReduce jobs in Spark, um,
Mhm.
versus doing it yourself through in Java and doing it manually more or less. Do you lose
Actually, we are
any
not saying
level of
MapReduce job. We are simply saying it's a map and reduce functions are there, like
yeah,
inbuilt
yeah.
function. Yeah.
Yeah, so
You
when we use those inbuilt functions, do you lose any level of like control using that? So or can you write custom
see
reducer
control
using that?
part if I yeah, okay. So you are saying here reducer, right? You are saying you have the control, right? You can write multiple output file, right? So
Mm-hmm.
in the Spark, right, when you are using the Spark, three data structures are there. Okay, one is a RDD, data frame, okay, and data set, right? These are the three data structure, right? Generally we say list, array, map, right? So these are the data structure for any programming language. When we say in Spark data structure, so Spark fundamental data structures are these three, right? These are the three base data structures. Like either we use a RDD to write our program. Second one is either we use a data frame to write our program in Spark, or third is a data set. So mostly we use RDD and data frame. So you were saying, like, suppose if I write whether I have a control or not in this map and reduce. Okay. So I say
Mm-hmm.
it is more customization is there. Okay. So this map function you are using, but you can implement your map function and you can customize your map function. Okay. So if I say the data frame dot write dot, there is a option coalesce. One function is there, coalesce. Suppose how many files you want to distribute your output, just write it. So your data frame is divided into the number of output files. Okay. By default, it will give one, same like MapReduce, right? Okay. So here is also customization is there, right? Library function purpose is to reduce the code, like productivity is improved.
Right.
Okay. Performance is also improved here, right? Because you are writing less code and you are using library function. So less code you are executing. Okay.
Yeah.
And a Spark is the in-memory computation. The best advantage of the Spark is that's the reason Spark job you cannot run in a less memory. If you say like, okay, I have a 8 GB RAM, so you will get less performance. And if you have a 64 GB RAM, you have a better performance. So so here is a RAM is a constraint, right, in the Spark program. But MapReduce there is no constraint because it's a batch processing only, right? So it is not using any in-memory computation, right? So MapReduce will run its own way and it will definitely take time. But when you have a constraint, right? Okay, you want your job faster and you want to get the result sooner, right? So you will be going for the Spark. So memory is not constraint, right? Nowadays, like earlier we think about, right? Okay, like, okay, 10 years back, the memories are like 1 GBs, 2 GBs, 4 GBs is enough. Nowadays is a 64 GB, 120 GB. So memory is becoming cheaper, right? As the time is coming, right? Okay.
Mm-hmm.
So if the performance is the constraint, so memory will not be constraint, right? Memory we will be using better and better, right? Okay. Right.
Right. Okay.
Because performance improvement is because if I say my job is through MapReduce, it's taking 10 hours to complete. Okay. And the same job, if I'm doing with the Spark with in-memory computation, suppose it taking 2 hours using Spark. So So I can utilize my resources for other work, right? So 10 hours, my all the resources are occupied, right? For 10 hours, right? So I'm not able to do any other work because resources are limited, right? Because resources are, you cannot increase the resources day by day, right? Because if your workload is increasing, you cannot increase your resources like CPUs, memories, right? So you
Mhm.
have to utilize your resources, same resources, but if you can complete your job faster, so you can use for the other job, right? So 2 hours if you complete, so rest time we can do some other job, right? So that is the thing, right? So we have to decide, right? Like MapReduce is better or Spark. So definitely the Spark is better, right? But why we are
Mhm.
learning, just I'm saying like understanding concept, right? Concept is important, right? Okay.
Okay.
Okay, so tomorrow we will do Hive. Okay, this is completely new topic and I will share a one slide. So meanwhile now you can go through today this slide. Okay, so it will be better, like you will understand more clear, right? Because this is the complete like an installation thing. Uh, in my document, this is the their installation document, right? You can see the Hive installation. Okay, so or otherwise I can show tomorrow some person. It will take hardly 10 minutes. Okay, so I will install one person and then everybody can see. Okay, installation is not big difficult. So Hive is completely now the SQL. So SQL is like creating tables, database, right? All this table command, right? So it is more interesting than the MapReduce because it's a SQL, right? Now we are jumping to the next topic is a SQL, right? So SQL is Hive, views is there, joins are there, left join, right join, outer join, full outer. So as much as SQL, you can go through some other SQL documents are there. Like you can go through W3 school SQL, any SQL, right? It's not relate. It's not like you have to read Hive in SQL. So even you can read any SQL. That is good. Just basic SQL concept, right? Like these all SQL things. So it will be all utilized in the Hive. So Hive, I told, is completely SQL based tool, right? So as much as SQL you know, you can use Hive better and better. Okay. But Hive, not only SQL, there are the partition, bucketing, surdays, UDF, lot many things are there which are not there in the SQL. Okay. So you can see like Hive is more than the SQL. So everything is in the SQL, it will come in the Hive. But whatever is the Hive extra, that is not in the SQL. Okay, I will talk about like partition, different file format data. So just go through this PPT. I will upload in the classroom so you can see there. Okay.
Okay.
Okay. Anybody else has any question? Okay. So I will upload in the same. You can see this YouTube after 1 hour. I will upload. Okay, because same like this my playlist, right? So it will be there only. Okay. So I will upload first the YouTube video and then I will upload. The code is same. You have already my. I think you have my this source code. So source code is this source code. You have this complete project I have already shared with, right? This same project, right? This all classes, correct? So I'm using the same classes. Yeah, data set is not there. Okay. So I will upload the data set, like whatever data sets you use here. So distributed cache related file, reduce side join file. Okay. And partitioner one, right? Partitioner example you can use for anything. Okay. But the distributed cache is that is employee.text file and department.txt. Okay, so this file I will copy in my Hadoop file system. So here it is there. Even that is there. So I will upload it all this file. This input data I will upload it. So you will
Okay.
get all the data. Okay, um, just first you import the code and just first you try to run in the local. Okay, distributed cache we can run in the local, but here sometimes the issue will come like you are giving a local path for the driver here in the this one. This is the mapper. Okay, this is the driver. So here is this path. Sometimes it doesn't work, right? Because it says like it should be Hadoop path. So if it is saying it needed Hadoop path, so in that case we have to use Hadoop path only. Okay. So distributed cache can be created locally also, like in our local file system. But see, everything we have to use finally on the Hadoop file system. Even we test it locally, but we have to test end of the day is on the cluster, right? Okay. So this directory you create in the cluster and upload the file, copy the file, and then use the command. Okay. I will copy the command also, Hadoop jar command for each example. So only 2 examples you have to do. This mapside join and reduceside join, the 2. Okay. Other one I have already given. Okay. Partitioner and combiner. Partitioner, combiner, and word count, these 3 are in a one example in this class. So here you can test that your partitioner, combiner, and simple word count without partitioner and combiner. Okay. The total 3 examples are this, and 2 examples are your mapside join and reduceside join with distributed cache. Right, mapside join with distributed. Okay. Okay.
Okay.
See you tomorrow. Yeah.
Okay. See you.
Thanks, Arvind.
Thank you, Arvind.